We're going to do to plan a synthesis of these compounds starting from acetylene, and that's why I have these 3 arrows. So see what reagents do we need to go there. So first step, as always, we want to see if the number of carbons have changed, if there are changes in the skeleton. So here we have carbon 1, 2, 3, and 4. And in that, I need to add more carbons, plus, of course, the functional groups. But I need to have 2 more carbons in the main chains. So basically, I need to, adding 2 carbons from acetylene is relatively easy. We have studied that in other reactions previously. We can do this by first doing sodium amide. And remember, this is a plus, minus. We will remove one of the acidic hydrogens here of the alkyne. And then in doing that, in the second step, we're going to add ethyl bromide. And that way, I'm going to be having the 2 carbons that I need. So looking at what is the mechanism of that, doing that quickly, removing that hydrogen, you will be making the following anion. And then you will make, I got to do it this brighter. Okay. Let's get this, yeah, I like that better. And we will do this as acting here. So that's an SN2 reaction. And your product here would be then, you have this as your acetylene and 2 more carbons. So I have the number of carbons that I need. Then let's see what we have here. I have added in the product, I have a bromine and an OH. And there is a reaction that we have studied from alkenes that allows you to do that. But first, I need to do something. I know that alkenes, let's write it down. If I had, say, an alkene, and I do bromination in the presence of water, then you will do, you guys remember that we will do, say, a bromonium intermediate here. And then you will have the attack. Your nucleophile is going to be water instead of bromide because it is in larger quantities. So when you do that, you will be forming then, here you will have opening up bromine, and then you will have, say, well, after the first step, you will have an extra H. And then you will have, again, the OH, and after removing that, say, water acting as base, removing the extra hydrogen here, you will get the final product, which will have opposite sides, because the addition is always anti, you will have that. So, okay, I know that I need to do that. But first, I need to make an alkene, and I don't have an alkene yet. So I use that to increase the number of carbons in the chain. But what I'm doing now is I need to make a hydrogenation reaction, and I need to create, it has to have a poison catalyst so that we form an alkene and not an alkane. So here, what we're going to do from this step, we're going to be adding, not writing much. This is not working great. Okay. Better. So here we're going to go into hydrogenation, but here we're going to be using Lindlar catalyst so that we get the alkene. So I'm going to write, say, the alkene structure. And this hydrogenation will happen in a scene fashion. But since here we have only hydrogens, we don't have an issue of forming 6 strands. And so what I need to have is then 1, 2, 3, and 4 carbons, 1, 2, and 3, and 4. And now I have the skeleton that I need. So I want to go there. So what do I need to do to get to the product? So again, I need to add bromine and the OH. So my strategy then will be to doing this bromine in water. So same that we did here. So we're going to add bromine and water. We're going to form the bromonium, and then we will have the attack of OH in this carbon. And that is essentially it. So Again, first step, always check the number of carbons that you have in the final product. It was 4. We had at the beginning only 2, so we need to add carbons. An easy way to do that is through your acid-base reaction with sodium amide, having the anion react via SN2 with ethyl bromide. You had added the carbons that you need, and then you do a hydrogenation, the alkyne to the alkene using a poison catalyst, and then the bromination in water.